Okay, let's go ahead and get started. Any homework questions before I start the rest of section 5.2? Has this one been okay so far? 5.1? All right. Again, anybody need one of the 5.2 handouts from yesterday? I only have one. So, I don't know, I feel like this is unfair if I just give it to one of you. Okay. I will send or post a copy of it. So, just, I guess, take notes for now. I'll make sure I write everything on the board so that you're not missing anything if you just write it all down like so. Okay. So what we were talking about at the end of class yesterday was supplementary angle identities. And from the unit circle, we inferred the first two, that sine of 180 degrees or pi minus theta is always just sine of theta. Cosine of 180 degrees minus theta is just the same as cosine theta. If I'm not mistaken, to have one of these is a negative. So what do I do when I'm not sure? I draw the picture.
The cosine is negative.
The cosine is the negative one? Well, just to kind of maybe just go through how you figure something out if you're unsure. So for simplicity, just assume the angle theta is in the first quadrant. And then the coordinates of this point are cos theta, sine theta. Okay. And then I can draw the 180 minus theta angle. That's going to end up being, well, you start in standard position, you go 180 degrees and then subtract theta. And you maybe grab blue for this. Okay, so this angle right here is 180 degrees minus theta. And the coordinates of this point are cosine 180 minus theta, and the y-coordinate sine 180 minus theta. And if you look up here, yeah, I think you were right. You said the cosine has the negative because these y-coordinates are equal. So sine 180 degrees minus theta is the same as sine theta. But the x-coordinates of these points are negatives of each other. So cosine 180 degrees minus theta is minus cosine theta. Okay. And then tangent, we're going to actually use those two facts to figure it out in the next example. So example 3, we're going to use supplementary angle identities to discover what tangent of 180 degrees minus theta is. Okay. So back to the definition of tangent, it's the y-coordinate over the x-coordinate, or we always know it's sine of the angle over cosine of the given angle. So tangent 180 minus theta is sine 180 minus theta over cosine 180 minus theta. And Brittany, I ran out of handouts. I don't know if you had one from yesterday, but okay. And then I got some stuff to pass back, so don't forget before you leave class. Okay. So what are my supplementary angle identities now? Tell me the numerator and denominator are. So the numerator, sine 180 minus theta, is just sine theta. And the denominator would be negative cosine theta. The negative can come out front. So maybe a little reminder. Again, you'll see me do this quite a bit, but if you do minus a over, so the negative can be in the numerator, it's the same as having the negative in the denominator, or it's the same as pulling the minus in front of the fraction. So that's just a little algebra fact. So this is minus sine theta over cosine theta, which ends up being minus tangent theta. So that would be the third supplementary angle identity. Oops. Okay. And remember, 180 degrees could also be replaced with pi if you're working with radians. Okay. These angle identities, there's times where they're important to use. There's also times where they're not so important. Okay, so I'm presenting these identities here. We're going to be working with a lot more identities again later in chapter 6. Okay? In fact, I think all of chapter 6 for the most part is about showing that identities are equal using other various identities. Okay, so I'm presenting them here. I'm not sure. They are useful in certain situations. You can probably get around using these using other facts like the unit circle and triangle trigonometry, using reference angles, coterminal angles. So there's lots of other ways to achieve what you're trying to solve without having to use these identities. But when they are pertinent or relevant, I will bring them up again. Okay. Now, in my next box on the next page, on page 3, I actually have a mistake because at the top it says angle determined by a point, but the bold inside the box should not say supplementary angle identities. So when I copied and pasted the previous box, I forgot to change what I had there. So this should really just read angle determined by a point in the box. You can just cross it off if you like. And it says let theta be an angle in standard position. And then for the folks that I wasn't able to get a handout, I'll just post it on Canvas. So if you want to save yourself some writing, you don't want to rewrite all this stuff. Although it's usually good practice to just rewrite all your definitions anyways. Okay, so let theta be an angle in standard position whose terminal side passes through the point Q, and we'll just say the coordinates of Q are just x comma y. And then R, for radius, is the distance from Q to the origin. Okay. Everybody's okay with origin is just representing the point 0, 0 in the coordinate plane? Okay. Okay. So I'm going to draw a picture as usual. For simplicity, I'm just going to draw it in the first quadrant, but all these facts remain true in general. So here's the origin 0, 0, x-axis, y-axis. It's going to point to the point Q with coordinates x, y. I'm going to draw down this little horizontal or this perpendicular to the x-axis to form a right triangle. And then theta is the angle in standard position whose terminal side goes through that point xy. Okay. And then what did I say? This up here is going to be the distance r. So that the distance from the origin to that point Q is going to be r. Okay. Now, the reason I chose to do this in the first quadrant for simplicity is if we're in the first quadrant, both the x and y coordinates are going to be what in sign? They will both be positive. So x is just going to be the base of this right triangle. That's the horizontal distance to get to this point. Y is just going to be the vertical distance to get to that point. Okay. So on your papers, you might see that we have r is equal to the square root of x squared plus y squared. So where am I getting that from? What theorem is going to relate x, y, and r? Yeah, that's going to be your Pythagorean theorem. By Pythagorean theorem, x squared plus y squared equals r squared. And then if you take a square root on both sides, that's how you get r. Typically, what do you get when you take square root of both sides? You should make sure in general that you put a plus or minus, but why did I ignore that this time?
Is in the first quadrant everything positive?
Okay, that'd be one way of maybe thinking of it, but more specifically, r is supposed to represent a distance from the origin to a point.
And negative?
Yeah, and distances can't be negative. Perfect. Yep. Okay, so we choose positive square root of x squared plus y squared for r. Okay. And then, given that angle and the coordinates of the point, you can find the values of sine theta, cosine theta, tangent theta. And there's a formula in the textbook for recovering the angle. I don't like the formula. Okay? I don't like memorizing that many formulas. I would rather just have everybody draw the picture and use their triangle trigonometry to recover the angle. Maybe use arctan, arcsine, arccosine. Okay, so there is a formula for the angle, but I would just prefer, it's not something I like to memorize. I like to just draw the picture and just heuristically kind of reason out what the angle should be, rather than try and memorize a formula every time. Okay, so you look up here now, we can apply sine, cosine, and tangent to this angle. So using that right triangle, what's going to be sine of theta? So remember, think of your, what am I always thinking in the back of my head? What's that little mnemonic again? So you can always think of SOHCAHTOA.
Should it be y over r?
Okay, so for sine theta, it's going to be the y-coordinate divided by that distance from the origin to the point. Okay. Cosine theta, in general, is adjacent over hypotenuse. The side adjacent to the angle has distance x, and the hypotenuse has length r. So cosine theta is going to be x over r. And tangent theta is really sine theta divided by cosine theta, but if you take y over r divided by x over r, and let me write this down here in case it gets cut off. So if I do y over r divided by x over r, what's the trick for dividing something by a fraction? Instead, you multiply by the reciprocal. So the reciprocal of x over r is r over x. The r's cancel, and you're just left with y times 1 over 1 times x, which is y over x. So for tangent, it's the same formula as if you were on the unit circle. Okay. One thing I want everybody to maybe notice or think of, this point is just a point on a circle of radius r. I can try and draw it in here for everybody and hopefully not screw it up. There we go. That's not bad. That might be the best circle I've ever drawn in my life. Okay. Except for at this point right here, I have a little screw up, but I think it looks pretty good.
The more you practice, the better you get.
Yeah. Okay, so you can. That's another way of thinking of it, is that this point is really just on a circle of radius r. The coordinates, if I knew the angle and I wanted to recover the coordinates, I could just multiply the sine and cosine by r to get y is r sine theta and x is r cosine theta. So if you like, you can remember that. Okay, so if you're on a circle of radius r and you're specified an angle, instead of the x-coordinate and y-coordinate being cosine theta sine theta like on the unit circle, you just multiply by the radius this time. And does that agree with being on the unit circle? So the radius would be 1, right? The x-coordinate's always cosine theta, and the y-coordinate's always sine theta. Okay. And then, like I said, if you know the coordinates of the point and you know the distance, there is a formula for the angle in the textbook. You're free to read it and use it if you want, but I usually just use other methods to find the angle. Okay. I think everybody has enough stuff to remember. Okay. So generally, ultimately, I think that's the goal in a class like this. Yeah, there's basic things that you need to memorize, but usually, you know, there's only so many things that we can remember. So it's usually better to just reason through things than to just try and memorize a bunch of facts blindly. That's my opinion, but okay. So let's do an example. So we're gonna take an angle in standard position whose terminal side passes through a given point. We'll find sine theta, cosine theta, tangent theta, and the angle itself. Okay. So let me come over here. Example 4. Grab something more robust. Okay. So theta is the angle in standard position whose terminal side passes through the point, what do I have, -1, +3/2. So as usual with these things, I think before you try and do anything, you should ultimately draw your set of coordinate axes, the x and y axis, and then you should label this point. So you can go 1 unit to the left, so that's telling you to go 1 unit left. 3/2 is telling you to go the y. That's the y coordinate. You want to go up 3/2. So we'll say that's 3/2 right here, and there's our point -1 3/2. And then theta is the angle in standard position whose terminal side passes through the given point. And then I will use this in a little bit, but if I draw a perpendicular, or a line perpendicular to the x-axis from this point, we've now formed a little right angle. Okay. So where do I want to go with this next? Okay. Keep in mind that's the x-coordinate, that's the y-coordinate.
So far.
Okay, so if I want sine theta, cosine theta, you use the x and y coordinates, but you have to divide by the distance from the origin to that point. Okay, using the formula over there, r is going to just be the square root of the sum of the squares of these coordinates. So you get -1 squared plus 3/2 squared, and we are going to simplify that.
I got 3 square root 5 divided by 5.
You got what?
3 square root 5 divided by 5.
3 square root 5 divided by 5?
Yeah, like 3 square root 5 on top of 5.
Okay, let me check that. That sounds a little bit different than what I got, except you might have a different form. So, since we're working with fractions, I'm going to do this by hand. -1 squared is +1, plus 3/2 squared, you square numerator and denominator, you get 9/4. So that's 1 plus 9/4.
Right.
I'll get a common denominator. So this is the square root of 4/4 plus 9/4. So 1 is the same as 4/4. Okay, so when you add these fractions, you're going to get 13 divided by 4. So I just add the numerators and divide by the common denominator. And then you can take square root of top and bottom. Square root of 13 over square root of 4 is going to give you a 2 in the denominator. So the distance from the origin to this point, -1 3/2, is just root 13 over 2. Okay. All right, everyone okay so far? All right. And then, let's see. So now we can do sine theta. The formula over here says it's the y-coordinate divided by the distance. The y-coordinate is 3/2, and then you divide by root 13 over 2. And then instead of dividing by a fraction, you can multiply by the reciprocal. And you get, Chris, you said 3 over root 13? Well, if I multiply by the reciprocal, the 2's cancel, but the 13 stays in the denominator. Yep.
But you can switch it to the top, so it'd be 313 over 3. I think it's what he's trying to say.
No, I was just
Okay.
Yeah, it should just be 3 over root 13 unless you want to rationalize the denominator by multiplying top and bottom by root 13. Okay. I typically don't rationalize denominators because to me it's just more work.
Yeah.
I mean that's an exact answer anyways, so. Okay. And then what about cosine theta? What am I going to get when I do that? So you get negative 2 over root 13, you said? Yeah, I think that's right, because you do minus 1 over the distance r, root 13 over 2. Yeah, and when you multiply by the reciprocal, you get minus 2 over root 13. Perfect. So I just took the x-coordinate divided by the distance from the origin to the point. And then tangent theta, well, you can think of it this way too. It's just sine theta over cosine theta. However, I think it's easier to just use the formula of the y-coordinate over the x-coordinate. The y-coordinate is 3/2. The x-coordinate's negative 1. And then that just gives you a minus 3/2. So there's sine theta, cosine theta, tangent theta. Yeah.
If we're trying to find the angle, do we have to do all 3 of those?
No.
Okay.
No. So I'm just finding the values of sine theta, cosine theta, tangent theta without finding the angle, and then that's the only way I think you could really find those values exactly. Because if you knew the angle and tried to plug that in your calculator, it might not necessarily spit out the exact answer in terms of the radicals. Okay, so this was just getting the exact values of sine, cosine, and tangent. Okay. Now, again, there is a formula for finding the angle using arctan, but again, it's just not a formula I like to use. So here's a little trick I'm going to do. Instead of finding the angle theta first, I'm going to draw this little angle inside of the right triangle and call it beta. Okay. And what do we know about beta plus theta? What do they have to equal in degree?
180.
Yeah, right? Because if we're together, both these angles are going to give me half a rotation, which is 180 degrees. Okay, so one thing we know, the angle that we're looking for, theta, is just 180 degrees minus that beta inside of that triangle. So what I do is I take that right triangle and extract it. That's the angle beta. And then I know the base and the height. The base is going to be 1 unit. Okay, you ignore the negative because we're just talking about a positive length. Okay, so the base has length 1, and what about the height? Yeah, that'll just be the y-coordinate 3/2 because we have to go up a distance 3/2 here. Okay, and then how can I find beta? So first of all, let's set up an expression that involves beta. What trig function can I apply to that angle? Okay, since we know the opposite and the adjacent side, tangent of beta is just, well, it's root 3 over 2 divided by 1. Root 3 over 2, Chris. Too many radicals all over. It's 3/2 divided by 1. And then, how do I find the angle now? We just convert to arctan. So beta is going to equal arctan of 3/2. So this is 180 degrees minus arctan of 3/2. Make sure your calculator's in what mode? Oh,
Degrees.
we're subtracting it from a degree angle, so your calculator should be in degree mode. And then what do you get rounded to 2 decimal places? Do you get 56.31? Have someone else confirm.
Yeah.
Okay, sweet. Now, does that answer make sense? I'm kind of I'm not as satisfied with it. Is that the just arctan measure? So we actually needed to subtract from 180, sorry.
That's 123.69.
How did I know my answer didn't make any sense if it was just the 56 though? Here, this would be a 90-degree angle. Theta's got to be more than 90 degrees. Because it's obtuse, exactly. And what do you get when you do the 180 minus this arctan though?
123.69.
Alright, that sounds better. Okay. 6.9 you said?
Yep.
Okay, sorry. You're at 5. So that would be the angle that from standard position has terminal side pointing to the given point, negative 1/3/2. And again, there's a formula for it, and it's actually a piecewise function. You have to remember the formula based on what quadrant the angle is in. So rather than memorizing another formula based on quadrants the angle's in, I thought it was just better to use what we know about triangle trigonometry. Form this little right triangle. Now it's going to be different depending what quadrant you're in. My given angle, my point might have been in this quadrant down here. Okay, so in that case, theta would have been 180 degrees plus the angle inside the right triangle. Okay, so it's going to be a little bit different depending on where your point, what quadrant your point is in. Okay. Everybody okay so far? Okay. We're doing on time. Doing just fine. Okay. So now what we're going to do is we're going to form angles that are given by lines passing through the origin. This might be the first time that we've really done some pre-calculus 1 extensor. It's the only time I think so far we've really used anything directly from pre-calc 1. Okay, so example, is it 5?
Yeah.
Okay. So theta says find the measure of the acute angle formed by the line y equals 4x in the positive x-axis in quadrant 1. Okay, so find the acute angle theta formed by y equals 4x. That's a line that's going to pass through the origin because when you plug in 0 for x, y is equal to 0. And the positive x-axis. And I'll just write Q1 for quadrant 1. Alright, so let's, again, what am I going to probably do first? Yeah, we're going to draw a picture before I even do anything. So here's the xy coordinate axes. Now, y equals 4x is a line with what for its slope? Yeah, so remember this is in the form mx plus b where the coefficient on x is the slope. So this thing's going to be a little bit steeper than the line y equals x. So this is the line y equals 4x. And what we're trying to do is find that angle right there formed between the line and the positive x-axis in the first quadrant. Okay. Now here's a little trick. If I'm going to use that angle determined by a point summary in the previous page, what we should probably do is pick some point on the line. What's the easiest thing I could probably plug in for x, other than 0? 1. So I can plug in 1 for x, and then what would be the y coordinate I would get out of it?
4.
You would get a y coordinate of 4. Okay. Let me actually label my line down here. And then let's say this now is the point 1, 4. So just plug something in for x to get a y coordinate on the line. That'll give you a point. And then using that point, we should be able to recover this angle. Now again, you're not always going to be looking for an angle in the first quadrant. I think this is maybe one of the simplest scenarios you could have. So what am I going to do with this triangle now? I'm just going to take this triangle and pull it out on the side. So there's my right triangle with angle theta. Since the coordinates are 1, 4 in the first quadrant, the base now has length 1 and the height has height 4. Okay. And then this is pretty similar to how we found the angle in the right triangle in the previous problem. So first of all, let's write down an expression involving the angle theta and those two other sides. So since we have the opposite side and the adjacent side, which trig function is always the most useful in this scenario?
Tangent.
Tangent. Okay. So now we know tangent of theta is going to be 4 divided by 1, which is just 4. And then theta is going to be arctangent if we just convert to the inverse function. And then it doesn't really matter, did the question actually ask for degrees or radians?
No.
No, but let's just stick with degrees because I think that's what they're mostly using in these sections.
75.9.
You get 75.96.
96.
Okay. Now, why does this answer make sense? Let's think for a
Because
second.
it's opposite.
Because it's not quite 90 degrees.
Yeah, it's not, this line is not vertical, right? So the angle has to be less than 90 degrees. And since the slope is 4, one thing I'll point out is if you're looking at just the line y equals x, that always forms a 45-degree angle, but if you increase the slope, it's going to increase the angle as well. Okay. So that's a reasonable answer. It's less than 90 degrees, but it's greater than 45. Okay. So I'm guessing there'll probably be, I assigned the written homework yesterday in the afternoon as well. There should at least be some sort of problem where you're finding the angle formed between a line.
Yeah, number 42.
And then one more, just an application problem. Okay. And these are leading into what we're going to be doing later on in this class. We're going to be describing, basically we're going to be doing some bearings problems or some navigation problems. Right? Think about being on the ocean and moving in particular directions. Bearings are given by so many angles north of east or so many angles north of west. And we'll get into that in more detail, but I think this example is kind of a little precursor to what we're going to be doing in later sections. So what it says is a motorbike travels across a flat sand dune. I should maybe write this down, although it's going to take up quite a bit of the board. Do you guys have the handout over there? Here's what I'm going to do. Do I have another one? Because do you at least have one from someone next to you? Okay. So motorbike travels across a flat sand dune. You're going to consider the start of the trip to be located at the origin 0, 0. Okay. So it's like we have a top-down view of this person riding this motorbike. The positive x-axis is going to be considered pointing due east. So first of all, let me draw that picture. So here's the coordinate axes. You're looking down from the top on this sand dune. Here's the origin 0, 0. That's going to be the starting position of the motorbike. And the positive x-axis, we were told, is the east direction. Directly upwards is going to be north, that's going to be west, and this is going to be the south direction. The destination is going to be a rock formation that's 11 miles north and 3 miles west. So what you're going to do to get to this rock formation, you're going to go north for 11 miles. You're going to go west for 3 miles, which is really bringing you to an x-coordinate of -3. And the rock formation is located up here at this point. It says, find the distance and angle the motorbike travels to reach the rock, as long as the motorbike follows a straight line path. So from this point, the motorbike is just going to go directly in a straight line path to there. And again, I'm going to exploit this little right triangle by drawing a line from that point that's perpendicular to the x-axis, Now, let's go ahead and label the distance between the origin and that point R. And the coordinates of the point up here are -3 and 11. So we went 3 units left and up 11 units. Now there's lots of angles I could use to describe the direction. Okay, I'm going to just do it in both ways. So one thing I could do is I could call the angle from standard position to the terminal side that goes through this point. We could call that theta. Or I could describe the position or the direction using that angle inside the right triangle and call it beta. And there's two kind of views you could take. One is the motorbike is going to travel theta, we'll do degrees. And one thing I could say is north of east. What that means is you're starting in the east position and rotating in the north direction. Okay, so it's starting in the east and rotating towards the north. So that'd be a north of east angle. Yeah?
Would your angle still be right if you just found the beta angle and then just worded it different?
Yeah, totally. On a test, for sure. Unless I said describe the bearings in terms of north of east. Okay. And then how would you say it if you wanted to use the beta angle? You'd say beta degrees. Starting in the west position, we rotate towards the north. So you could also say beta degrees north of west. Both of those would describe the heading, the direction that you're traveling. Okay. And like I said, we'll get into the bearing stuff in more detail later. Okay. I think what I'll do, certainly I think beta is easier to find. In fact, if I was going to find theta, I would find beta first anyways. Okay, so first of all, what's going to be the distance traveled? Let me make the south thing a little smaller.
It's gonna be square root of 30.
Okay, the distance traveled is r equals, and then how did you come up with that value?
Oh, our x squared plus y squared.
Okay,
Square root of
so you took, basically you're just taking the distance from the origin to this point, and it's always the square root of the x coordinate squared plus the y coordinate squared. 11 squared is 121, negative 3 squared is 9, so you said, did you get the square root of 130?
Mm-hmm.
Okay. And what are our units going to be there?
Miles.
Yeah, remember your east, your west and north units were miles. Can we get an approximation?
11.4.
11.4? Okay. So to go directly in a straight line path to this rock formation, you have to travel 11.4 miles. Okay. And then I'm going to write down both ways to describe the heading. Okay, just in case. The online homework might prefer one over the other, so I'll write down both. So I think beta is easier to find first. Now what you're going to do is, if you want to find beta, I'm just going to pull that triangle out. So this little right triangle here, I'm just going to draw it again over here on the side. Make sure all your sides, though, now have positive distances. So the base, since we went 3 units left, that really has distance positive 3. The height is really just going to be the distance traveled north, which is 11. And here's going to be that little angle beta. Technically, I could use any trig function to find that angle now if I wanted to, because I also have the hypotenuse if I need it. Okay, but generally, if you know the opposite and adjacent side, you can start by applying tangent to that angle, which is going to be 11 thirds. And then beta is going to just be arctan of 11 thirds. And let's do that in degrees. 2 decimal places is fine. So what do you get, Martin? You get 74.74? Okay. So what you can say is you could say the motorbike travels 74.74 degrees north of west. And then, how'd you get that second one? So Martin calculated the other angle. If I want to describe it in terms of theta,
wasn't that just or take 180 minus beta?
Yep,
I got 105.26 degrees.
what was it?
105.26.
3.6 or 2.6?
26.
Okay, so yeah, you could describe it by 74.74 degrees north of west or 105.26 degrees north of east. I'd have to look at the online homework. They might always want the angle theta when you start in standard position. And they might not make you phrase it in this north of west or north of east. I'm just doing that just so we've all seen it before when it becomes more relevant or pertinent. Okay, so when they say the angle theta, my guess is they actually want the one from standard position. That's the north of east angle. Alright. Any questions there? We found the distance you need to travel in a straight line path, and we described the direction by giving either one of those two angles.
So, we usually do something like this on a quiz.
Sure.
And we decided to take beta plus 180.
Beta plus 180.
We just decided to take
Or
theta minus 180 and of beta plus 180. Just given our calculations, it kind of came out as a negative naturally.
I would say stay clear of using negative angles to describe directions.
It came out with the same result in the end. So
Okay. Yeah, let me see what you're doing real quick because I'm not quite sure. But yeah, I would stick with either of these two positive angles if you ever came out with a negative. But let me take a look at what you're doing, and maybe I can make a comment about it tomorrow when we start class if it's something that is important. It's 10:13. Does anybody have any questions, or I guess I should probably be caught up by now and giving you time back. I've probably stolen a couple minutes a few times this quarter, so that's all I got for new information. We'll start section 5.3 tomorrow. There will be a quiz on section 5.1. So the right triangle trig.
So not 5.2, just 5.1?
Just 5.1 because you haven't finished the homework for this yet.
And the quiz is tomorrow?
Yep.
And the homework isn't there?
Okay, thank you.
I won't be here tomorrow.
We can make it up on Monday again.
Okay.